Hello everyone, welcome to my channel. So today I am teaching you Laplace transformation. So what is Laplace transformation? The basic formula of Laplace transformation is like this. Laplace of ft. Laplace of ft is equal to integration 0 to infinity e to the power s minus st ft dt. Here Laplace means three parts: the integration part, the exponential part, and the functional part. So here is the s and t two terms. T will be related to this t, and ft of here and ft of here is the same. Now I will teach you the short technique how to derive any Laplace formula. So first of all, we just know what is Laplace of 1. Laplace of 1. Okay. So by the principal formula, Laplace of 1 like e to the power minus st and 1, then dt. Okay, we can write this like, okay, then the integration of this, that is e to the power minus st, and for the integration of minus st we can derive minus s into the denominator, then the limit 0 to infinity, and the final result is 1 by s, because e to the power minus infinity is equal to 0 and e to the power 0 is equal to 1. So from this we can get 1 by s. And now I will teach you how to derive this formula and how to derive the Laplace transformation without using these limits, just by the first formula, that is limit of 1 is equal to 1 by s. We just use this formula. So trying to find the Laplace of e to the power at. So what, let's try. So by the formula we know that 0 to infinity, but we don't use this limit on it. Let's see how to do it. E to the power minus st and e to the power at dt. Okay, clear? Then we just convert this two e to the power terms into one term, that is minus of s minus a t dt, and now just relate this term with this term, integration of 0 to infinity e to the power minus st into 1 dt. So by relate two terms we can conclude this, that this will be 1 by s, so this will be 1 by s minus a. So this is the shortest formula. Then the next one we use this formula, that is Laplace of e to the power at. We just use this formula, that is s minus a. So we are trying to find the Laplace of sine sine 80. So how can we find this value? So for this we should use Euler's theorem. By using this, we know that e to the power I theta is equal to cos theta plus I sin theta. Here the cos theta is the real part and I sin theta is the imaginary part. Now this theta, we can change this theta with 80. So let's change this with 80, that is e to the power I 80 equals to cos 80 plus I sin theta is equal to I sin 80. Now use Laplace in both sides. Using this, can get e to the power I 80 and Laplace of cos 80 plus I Laplace of sin 80. So by the Laplace property we can get this I by outside of the Laplace. Okay, then this is relatable to this formula, that is 1 by s minus I 80. Like here it is 80 is equal to a, so I 80 is equal to IA, sorry, this T not here. So and the right hand side was same, cos 80. We don't use the limit to simplify the problems, just comparing two terms. So this is the final so here I solve the next line, that is, you can see this, the term that is 1 by s minus IA, I just multiply s plus IA in upward and in denominator and numerator, s plus IA, and the rest of the part s minus IA same, Laplace of cos 80 plus I Laplace of sin 80. Now here see, this was a formula of a square minus b square. By this I can write s plus I a, and in the denominator s square minus I a whole square, and the right side should be same. So notice that I don't use the limits. If you use the limits to derive this Laplace transformation, it should be complicated. So by this I can write this as s plus IA by s square minus should be changed in plus a square, because that is I square equals to, we all know, minus 1. So putting here minus 1, it should plus. So a square plus a square. And the right side should be this cos 80 and plus I Laplace of sin 80. Now the next term, we just separate these two terms, plus I into a by a square plus a square, and the right side should be same, that is cos 80 I sin 80. Okay, now we just compare these terms. This term s by